start by talking about the area problem. So if you have nice shapes like the following, if you have your x-axis and here you have your y-axis, and somebody asks you, what is the area of the following rectangle? Suppose the lengths are given as A and B. You're going to say that, hey, the area of this two-dimensional object is nothing but A times B. The area becomes A, B, whatever A and B are. But if I ask you to find the area of the following two-dimensional object, find the area. So in that case, I'm going to give you the following object, two-dimensional object. We have x and y, and here you have your parabola, y equals to x squared, and I ask you, hey, find the area of this object bounded between 0 and 1 below the graph. Okay, between 0 and 1, what is this area? Well, to find the area, we can use approximation. This is the very first thing before we introduce the shortcuts in finding the integrals. Approximation. So how does it work? We're going to divide up this two-dimensional object into smaller pieces. So I'm going to convert this guy into an object with smaller pieces. Make sure the graph is good. I'm going to divide this guy up into 4 smaller pieces. Y equals to x squared. And here I have these little pieces. So what I did, I just divided this two-dimensional object into 4 smaller pieces. I'm going to calculate each of these areas approximately, add them all together, and have an approximation for the area. I'm going to call this guy S sub 1, this guy S sub 2, S sub 3, and S sub 4. Okay, let's see. We divide the two-dimensional object into 4 smaller divisions. S sub 1, S sub 2, S sub 3, and S sub 4. Very good. So S sub 1 is defined on 0 to 1/4. These are all equally divided. So between 0 and 1, you have a half. Between these two, you have a fourth. And here you have 3/4. So take a look at this. What I'm trying to do, I'm taking each piece, 0 to 1/4, and on top of it, I have this guy. I'm just using this little piece and move this guy here. Then between 1/4 and 1/2, I have another piece with a different height, right? It's getting a little bit larger. Between 1/2 and 3/4. And then 3/4 to 1. I take these I add them together to get an approximation for this whole area. So 3/4 to 1. This is my last piece here. This is the very old-fashioned method to approximate the area of objects. So you might be wondering, hey, now how can I find each one of these heights? Okay, and note that this guy is tilted. It's not a horizontal line. One method is that, well, we can use heights from left. So we can find this height multiplied by length, approximate this little area, find this height multiplied by length, approximate this little area, find this height multiplied by length, find this little area, and keep going. Just add them all together. So we can use option 1, left endpoints. So if you use left endpoints, the height for this piece is just 0, am I right? So you get the very first point, 0. On this function, at this point, it is 0 height. So you get 0 height times the length, which is 1/4, plus. Now here, if you plug in 1/4 into the function to get this height, you have 1/4 to the second power times the length, which is another 1/4, plus. Now this length, to find this length, you have your x value, 1/2, plug that into the function, you get 1/2 squared times 1/4, which is the length, plus 3/4 to the second power times 1/4. If you add these together, you get a smaller approximation for this area. So what are we doing? We are taking this guy, we are taking this guy. These are all small rectangles. You're adding these together to have an approximation for the area. So using left endpoints, the area approximation of area L sub 4 is going to be approximately 0.21875. You might say, hey, why we don't use the right endpoints? This is the second option that you have. Option 2, the right endpoints. So if you use right endpoints, now to find this height, you're going to use 1/4. You have 1/4 to the second times the length, which is 1/4. If you use the right endpoint, x value is 1/2. So this length, you need to plug that into the function. So plus 1/2 to the second power times 1/4, which is the length. All of these have the same length. 3/4 to the second power times 1/4 plus 1 to the second times 1/4. This guy is your R of 4, which is approximately going to be 0.46875. So you can say that, hey, my area, the area of this object is going to be bounded between 0.21875 and 0.46875. So we have an approximation. We don't have any other tool right now to give us the exact area. Another option for you, option 3, is to use the midpoints. midpoints. So if you use midpoints, you're going to take the midpoint of each of these little parts, little sub-intervals, and plug those into the function to get this height here. So you have 1/8 to the second times a fourth plus the midpoint between these two guys. Here you have a half plus a fourth, which is going to be 3/4 divided by 2, or 3/8 to the second power times a fourth plus, now we need to find a midpoint between these two, 5/4 divided by 2, 5/8 to the second times 1/4 plus the midpoint between these two, 7/4 divided by 2, or 7/8 divided by 2 times 1/4, and get an approximation. And it's going to be very close to this area, but it's not very accurate. So none of these numbers give you an accurate area. These are not an accurate areas. That's why we're going to introduce the shortcuts to actually find the area for these types of functions.